Hello, I've missed you all. Thank you so much for being here today. My name is Jenna Pederson, just like Bridget said, and I'm excited to talk to you about one of my favorite subjects, which is software development best practices, but with a twist of bringing those practices to our infrastructure. So I want to start with a fun fact about myself. Once upon a time, I had the phrase automated test fanatic on my business card. And that was a while ago, and I'm very passionate about automated testing and testing in general. I feel like there's always a place for testing in whatever you're doing, whether it be learning a new framework, working on a side project, or even deploying a large-scale application into the cloud. And the challenge, though, is that there is, you have to find this happy balance of how much and what kind of testing to do for it to be effective. And so we're going to talk a little bit about that. So first, with a raise of hands or a note in the chat if you're virtual today, how many of you are using infrastructure as code, or you work on applications that run on infrastructure that's managed with code? Excellent. Okay, great. And if you're not, that's okay too. There's something for you here as well. So just a refresher, infrastructure as code, it helps you automate deployments of your infrastructure. It lets you quickly provision those resources. It lets you do it consistently, so across different instances or across regions. And it lets you do that at scale. But what happens when something goes wrong? Well, maybe you've already earned this badge, the Works on My Machine badge. I certainly have. And maybe it works on your machine or your account or your region. But what can happen is when we are deploying many resources, hundreds of resources to the cloud using infrastructure as code, things can break at scale. And that blast radius is much wider. So more resources, more regions, more customers, and more dollars are impacted when this happens. So your infrastructure as code is code, and do you treat it as code? Are you version controlling it? Are you testing it? Are you code reviewing it? Are you pushing it through different stages of your CI/CD pipeline? And how do you know when that infrastructure is out of sync from your code or has drifted? And how do you verify and validate that what you built is what you meant to build? And how do you verify that what you built is actually built correctly? So that's what we're going to talk about today, is treating your infrastructure as code and minimizing that blast radius. So we'll touch on the different types of testing, test-driven development, testing your infrastructure directly, and using a CI/CD pipeline. So the cloud, it makes it easier to quickly provision infrastructure, but there's complexity with that scale. So if you're going to multiple regions or you have many different instances, that blast radius is a lot wider. It's more complex. And so infrastructure as code helps you manage that complexity, but automated testing can also help you manage that complexity. And so by building quality in from the start with some of our testing processes and processes like CI/CD, we can do that just like we would do our application code. We can do that with our infrastructure code and our infrastructure. So that's going to give us more confidence at scale and at velocity as we change or add to our infrastructure. So as you're building out your infrastructure testing strategy, you're going to take a similar approach to determining what kinds of testing you want to do that you would do with your application code. It's just going to be a little different testing, that's all. So you've probably seen this testing pyramid before, or a variation of it. The tests at the bottom are going to be fast and cheap. They're easy to create. They're quick to run. They give you feedback a lot faster. You can run them more frequently. The tests at the top are going to be slow and expensive. They're harder to maintain, they're often more brittle, and in the case of infrastructure testing, they can be more complex because it involves actually provisioning and deprovisioning cloud resources and actually running tests that hit those resources in the cloud. So we still need that balance of the fast and cheap tests with the slow and expensive tests. So if you're test driving your application code, why not do the same with your infrastructure code? So what's actually stopping you? And if you're not familiar with test-driven development, here's some of the benefits. It helps us reduce our defect rates. It can improve the overall design of your system. It is very focused on requirements, and what I mean there is it helps you build only what you need and what you intended to build, so you're not building extra things that can break later on. It's also focused on small chunks, and this is to help you isolate issues and fix issues a lot quicker when you do have them. And it also serves as documentation for your team and for the requirements of your system. And lastly, it also gives you confidence. And this is confidence in what you're building or what you're changing, so that when you do have to make a change, whether it's a planned change or it's a unplanned change, because those do happen, it gives you confidence in those changes. So with our infrastructure testing, we can also follow the test-driven development flow that we would with our application code. So the rules there, or the guidelines, or the steps for this flow are that we first write a failing test. So it might not compile, or it might just fail like a normal test fails. The second step is that we actually write only enough production code to make that one test pass. And then we improve on that. And we keep following that process, those 3 steps, the red, green, refactor steps, until we've built up more tests and more production code, and we've built out whatever it is, our feature or our stack or whatever it is that we're building. So let's talk about those cheap and fast tests for a minute. So unit tests, they're going to exercise a small part of your application or one unit and verify that it's correct. Traditionally, unit tests are going to be isolated from other resources and from external APIs. So for instance, if you're building a CRUD app, you don't need to test the database and the access between the database, because we already know that works. That's already a relatively well-tested piece of functionality, so we don't need to be focused on that. We just need to be focused on what our part of that application needs to do. And because of this, this reduces the scope and number of variables that can affect the results, and helps us identify what actually goes wrong when something does go wrong in our code. So we can take this same process and apply it to our infrastructure code. And I say code here, not infrastructure. We actually don't need to provision any resources or even a little part of that to test what we're building and to test that we're configuring it correctly. And so when we have infrastructure-based unit tests, it's now checking that a resource is created with the correct configuration. It's the correct number of the correct number of resources is created, that dependencies between those resources are created, and that interpolated values are correct as well. So if you can imagine provisioning a database, and I did this several times as I was building up the demos for this talk, it's not a small amount of time to provision or deprovision a database if you do something wrong. It's like, for what I was doing, one instance, it was like 10 or 15 minutes to spin it up, and then another several minutes to take it down again. And as I code, I make a lot of mistakes, which is why I do unit tests. And so unit tests are going to help you with that process. So they're cheap to write, they're cheap to run. We can run them more frequently, which means we can get feedback into the feedback loop a lot quicker and know when something goes wrong. So I can write a test to see, did I configure this correctly? And if I didn't, I know before I've tried to provision that database that it's not going to be right. And we'll see that in just a minute. Again, unit tests are going to serve as they can serve as your documentation, communicating requirements to your team. Oftentimes, I've worked in a lot of large legacy databases, and when I go into a new database, I take a look. What are the tests that are there, and are there any unit tests? Are there any integration tests? And I can see right away if how a certain component works or how a certain stack is supposed to be set up if there's actually tests to look at. And additionally, because we're automating these unit tests, we can run them in our CI/CD tool, again, to get feedback into our loop a little bit faster. So in this first demo, I really want to show you that it's possible to test drive your infrastructure code. For context, this is an AWS CDK app, an infrastructure as code framework, and we want to create a private S3 bucket that has encryption enabled by default. So we're going to write a failing test with the Jest framework, a unit testing framework, and then we'll write the infrastructure code, which is our CDK code, and then we'll make sure that our test passes. So the first thing that we're going to do is, I've got some of this already bootstrapped. The project's here. The test is created. We're going to set up this test to have an S3 bucket stack. So we're going to create that stack in our test. And then we're going to set some expectations on that stack. So we're going to expect that this stack has a resource, an S3 bucket resource. And I want to make sure that that S3 bucket has certain properties set. And this testing framework, what it is doing is it is inspecting the CloudFormation templates that get generated by the CDK. We are looking at bucket name, we're looking at bucket encryption to make sure that those have been set. So once we have our test written, we'll go in and run the test. You'll notice that there was a compilation error there, and after we build and run this test, that's what it's going to tell us. We have a compilation error, and that's totally okay to have that on your first test, because a lot of times you have no production code there to actually test against. So that's what we're going to do, is create that S3 bucket stack. So this particular file is a CDK stack. We're just setting it up, the constructor, the way that this framework requires. And then we are going to create a S3 bucket here using the framework as well, and give it a name or an ID. This is not the bucket name or the bucket ID. It is just the logical ID of the resource in this framework. Then we give it a bucket name. We're going to block public access. And you'll probably note that I forgot to add a test for that. So later on, maybe today or tomorrow, I'll go in and add that. So then we build and run our test again, and it fails because I also forgot to implement something. So we wrote our test expecting that our S3 bucket has encryption enabled by default, and I forgot to add that to our production code. So, and I can see that here. There is a lot of output here, but we can see that there's a S3 bucket resource that expected bucket encryption, but it's missing. So go in and add that, and we'll rerun the test. and there should be a success here. So we have our code. We've got our code, and our tests are written, and now we can actually provision our infrastructure in the cloud. And once we've done that, though, how do we know that our infrastructure is actually correct in the cloud? I could go into the AWS console and tap, and manually check all my resources. I might have to do that across regions. I might have to do a whole bunch of EC2 instances and make sure that their dependencies are correct and make sure I have access to it all, make sure that different things are connected to each other, but that sounds like a lot of work. I don't like doing work. So what we can actually do is write some automated tests around that. So we can test our deployed resources, and that's where integration testing is going to come in. So an integration test is where we are testing the interactions across different units or modules, or in the case of infrastructure testing, we're testing the interactions across different cloud resources. We're verifying that our provisioned resources are created and configured as we expect them to be. And this is going to give you confidence in your infrastructure at scale and at velocity. So in the example that I'm going to show in just a minute here, we're going to use Chef Inspec, and this is an open source framework that lets you test and audit your infrastructure. And you can execute and write tests with a domain-specific language, so it's really easy to learn. And these execute on remote systems, so like servers, containers, cloud resources. And they can be used on any machine or resource, regardless of whether it's provisioned with an infrastructure as cloud or infrastructure as code framework, or if it's created manually. So if, for instance, maybe I have a stack of resources that I created with my framework, but then someone else goes in and creates resources on their own for something else, but they haven't actually put it into code yet. That can also be tested with Inspec. So the other benefit to this is that because these are easy to read and to learn, other teams can write tests. So for instance, your security team could write their own tests because they have certain standards that they want every EC2 instance to meet. And that would be written in an Inspec profile and then pulled into your test suite. So in this demo, I want to show you that it's possible to test your infrastructure code or your infrastructure directly, and that you can even test drive those tests right alongside your unit tests. For context, this is a different app. It's a CDK app again. There's already an EC2 instance and some related resources that have been created. They're provisioned already. They've been tested. And now we want to add a database to our app. So we're going to write a failing test in Inspec. We're going to update the infrastructure code. And then we're going to make sure that both our unit test and our Inspec test are passing. One thing to note, just before we get into the demo piece, a little bit more about Inspec and how that's set up. I've already created what's called an Inspec profile, and this is just a way for us to group related tests. Again, like I said, the security team might have their profile that groups their security-based tests. This framework, it's built on top of RSpec, which if you are a Ruby developer or if you're familiar with RSpec, it's going to look very familiar to you. Controls are, you can think of controls as your test file. So those are going to be declaring a requirement or a set of requirements about a group of resources. The describe block that we'll see here in a minute is grouping expectations for a specific resource. And then you can also, one interesting piece here is you can also set an impact, which is a number from 0 to 1. And the higher the impact, the more impact it has on your system if it fails. And so you can configure your test runner to pass or fail based on that impact score. So again, all of this is set up. We're just going to take a look at the unit test here. We're making sure that we have an EC2 instance that is configured correctly. We're making sure that there's an elastic IP for it. We've also added a unit test for our new database that we're adding, and we're expecting certain configuration values there as well. I've added some outputs to the CDK stack so that we can use them later on in our tests. We're going to build and run the test, and this should fail. And it's going to fail because we haven't actually created our database yet in our code. So if we go and look at our production code, again, we've got some of the supporting resources for our EC2 instance, security group. We've got the EC2 instance itself. We're going to make sure that that's set up as well. And then I mentioned those outputs. We'll use those in our tests, and we're going to add a couple new ones there for our database. But before we write any production code, we're actually going to write our inspect test as well. So we've got our unit test that's failing. We'll also have a failing inspect test. Just for a very simplified version of a test, because the other one's a little bit more complex, we have a control. You can see the impact here is set to 1. The describe block is testing against a specific resource, and then we have certain specific expectations on that resource with that ID. And so when we go to this, the full stack app control, before we do that, we'll look at files. There's nothing in there yet, but that's where our outputs will go from our stack. And this is just a look at the inspect profile. That depends block is where we put other profiles that we want to depend on. So if we had our security profile that we needed to make sure we ran those tests, this one here is giving us AWS support as well. So here we are, this is our inspect test that we're going to be updating. Right now, all it is doing is testing our EC2 instance and security group. And we've got these parameters here that I'm taking from an outputs JSON file. And we are doing that so we don't have to hard code those values in our test. So we've created the resources in the cloud, and we need those IDs of those resources to actually test against. And so we will use those in our tests. So quickly run this test just to make sure it's still failing. Or this one's going to be successful because these resources are already provisioned. They're already in the cloud. And then we'll go in and update this test to add, we're going to add a couple more parameters that we want to, outputs that we want to use as IDs that we're going to test against so we can find those resources. We're going to make sure that our database security group has access on port 5432, which is for Postgres. And then we're going to make sure that our RDS database instance is provisioned with the Postgres engine, a specific version, and a specific instance class. So again, here we're pulling in that database identifier from the outputs file that will, when we deploy our resources, we're going to get that data back. So once we've written this test, we're going to go back to the command line. We will run it again. And we're going to have that failure. And this failure is specifically because we don't have I think it was our outputs, the database security group ID and the database instance ID in our outputs file because we haven't provisioned that infrastructure yet. So we'll go into our CDK code, and we're going to add the database now. So we've added our database instance, we've given it an ID, configured it the way that we want it. We've given it an instance identifier. We've said we want it to be Postgres, this specific version, this instance type, giving it a couple of tags so we can find it later. And then we're also going to add this connection so that our EC2 instance can talk to our Postgres database. So that line there, we did not test in our inspect test or our unit test. So I think actually it's in our unit test, but it's not in our inspect test. And so that would be something we could add later. Then again, we need these outputs for our inspect test. So we're going to add database instance identifier so we can find that resource and run our test against it. And then the database security group so we can run our test against that as well. So once this is ready, so those outputs, they're going to show up here in just a minute once we've actually provisioned this, deployed it. So we've updated our test. Now we're going to go back to the command line, run our unit test again. So this unit test, we've actually written the production code for it, so it should pass, and it does. Now we're going to generate this CDK framework. Like I said, it's backed by the CloudFormation template, so we generate the CloudFormation template, and then we're going to deploy it to the cloud. And this is that process that I mentioned earlier that takes I think when I was recording this, it was 25 minutes or something obnoxious like that. And we don't want to wait around for that, so I sped this up a little bit. We're passing in any parameters that our stack needs, and then saying where should our outputs go. So our outputs from this deployment of these resources are going to go to that outputs.json file. So again, this is going to take a little bit. And we've got a successful stack and the outputs created. So now we can actually run our inspect test against our infrastructure. So this is testing, it's going out to the cloud and it's testing our EC2 instance to make sure it's there, it's running. It's doing the same thing with our database that we just added to our code. So we've built all this stuff up, but one thing that can happen is our code can become out of sync with our resources that are in the cloud, and that is known as drift. And inspect can actually come in handy here and test. These tests can make sure that our resources have not drifted from what we are expecting to be there. So other frameworks, they can only detect issues or detect drift for the resources that they know about, the resources that they manage or that's in your code. And so this is just one way of being able to detect that drift. And being able to do this gives you the freedom to choose whether you want to fix your code or if you actually just want to temporarily fix it in the infrastructure itself. So you might be wondering, Jenna, why did we build all these infrastructure tests? What are we going to do with them now? Well, that's a great question. So your CI/CD process might look like this today if you don't have any infrastructure tests, or maybe you don't have any tests at all, and it definitely looks like this, but that fire is really, really big. So you're probably not finding issues until they get to production. And if you're not finding the issues, your customers are. And so this is where infrastructure as code can come in handy, and it can help you with your CI/CD process because it relies on infrastructure automation in order to create consistent environments and to have a consistent test process and to be confident in each step of your environment or each phase of your pipeline. But when you do have tests in each phase, your fires are a lot smaller in between each of those stages. And then you are slightly more happy at the very end because hopefully you're having less problems in production. Your customers are finding less issues in production. So we can actually put all of this infrastructure code through the same CI/CD pipeline that we might do our application code. And this is going to help us find bugs earlier in the process when they're cheaper and easier to fix. So I just want to leave you with a few parting thoughts. I encourage you to code review, version control, test, unit test, integration test, run your infrastructure code through a CI/CD pipeline. Even if you're not testing your code in production, your customers certainly are. And the earlier you catch bugs, the cheaper it is going to be to fix. So thank you. If you have a moment, I would appreciate feedback. I hope this isn't the last time I get to give this talk. So I would like to make it better. Any feedback you can offer, whether it's through the survey link or on Twitter, whatever, I would greatly appreciate that. The bottom link here is a GitHub link to view the demo code that I showed. I know we went through it really fast, but it's all there. And yeah, thank you.